Hello, in this video we're going to talk about solids, liquids and gases. The first thing you need to be able to do is just describe the properties of solids, liquids and gases. So solids may be hard or soft, but they'll always have a fixed volume and a fixed shape. It doesn't matter what kind of container they're in, the shape and size of the solid is fixed. Liquids have a fixed volume, they can't be compressed, but their shape changes to fit their container, and they can flow and move around. Gases can change both their volume and their shape. The volume will change to fit their container. They can be compressed to become smaller in a small container or high pressure, and they can be expanded or released and will take up more space. The shape of a gas will change to suit its container, and gases, like liquids, can flow and move. As well as these basic properties, you're also expected to be able to talk about the particles in solids, liquids and gases. So in solids, the particles are packed really closely together. The particles can't move around or change places, they only vibrate, and this is what gives the solids their fixed shape and volume. In a liquid, however, the particles are quite close together still, but they're now able to move around and slide past each other, and this is what lets liquids flow and move. In a gas, the particles are spread really far apart, and they move around randomly in all directions. They can be compressed easily so the particles can get closer together, and they can also be released and the particles spread further apart. Once you've got the idea of the basic states, we need to be able to discuss changes of state, how solids change to liquids, liquids change to gases, and vice versa. So the first change of state we're going to look at is melting. This is when a solid changes into a liquid. This will happen at the melting point of the substance. This is an example of water, and you probably already know that the melting point of water is 0 degrees centigrade. When a solid melts, the particles start to gain energy from the surroundings, and they start to vibrate more and more and more until they can start to move past each other, thus changing from the solid particle model with the particles that can't move around into the liquid particle model where the particles can move past each other and flow. Freezing is the opposite of melting. It happens at the melting point as well, so the freezing point is the same as the melting point, which for water is 0. But this is now the opposite, when liquids change into solids. The particles in the liquid model are moving around, but as they lose energy when they cool down, they start to move less and less and less until they remain fixed in place, vibrating only, and that's when they're a solid. On the other end of the spectrum, a liquid turns to a gas at its boiling point, so this change of state is called boiling. At this point, the liquid particles that were close together and moving slowly past each other gain more and more and more energy until some of the particles start to escape. Eventually, all of the particles will have enough energy that they can break away from each other and start to move randomly in all directions. In this way, the particle model changes from the liquid to the gas. In water, this happens at 100 degrees centigrade, where water turns into steam. The opposite process is called condensing. Condensing happens at the boiling point as well, and this is the opposite change, gases turning into liquids. In the particle model, the gas particles have plenty of energy and they're moving fast in all directions. As they lose energy, they start to move less and less and less until none of them have enough energy to move away from each other, and they all stay close together as in the liquid model. There's one more change of state that's worth knowing about, and this is called subliming. This is when a solid changes straight into a gas without going through the liquid phase. As we know, in the solid, the particles are really close together and they can't move around. As we give them more and more energy by heating it up, the particles gain energy. But when they sublime, rather than turning into liquids where the particles are still close together, they turn straight into a gas and go from solid, where they're just vibrating, suddenly to being spread apart because they have so much energy that they can move around in all directions. So here is a summary of the changes of state. We can see solid to liquid is melting, liquid to solid is freezing. This happens at the melting point. Liquid to gas is boiling and gas to liquid is condensing, and this happens at the boiling point. Solid straight into gas is subliming. You can get reverse sublimation, but it's really unlikely that you'd need to know about that. One thing to note here is that we've given examples of water, ice into water and water into steam, with the melting point at 0 and the boiling point at 100. But remember, each substance has its own melting and boiling point. So some substances will have lower melting points, meaning that they turn into liquids at lower temperatures, colder temperatures. Some substances will have higher melting points, which means they turn from solids to liquids at much higher temperatures. So one of the things you'll have to do in the exam is be able to predict the state of a substance at room temperature or at a given temperature. So we should know that room temperature is normally about 20 degrees centigrade. So here we've got a table with 3 substances. It's important to note that the melting point is always lower than the boiling point because this happens in order: solid to liquid, melting, and then liquid to gas, boiling. So have a look and see if you can work out what state each of the substances will be at room temperature, 20 degrees. I'll give you a few seconds and then I'll tell you the answer. So, if substance A melts at 90 and boils at 360, at room temperature, 20 degrees, it's not going to have reached its melting point or boiling point yet, and so A will be a solid at room temperature. B has 2 really low melting and boiling points. They're below 0, which means that B will have melted and boiled before it got to room temperature. So B is going to be a gas. C has a melting point of 5 and a boiling point of 66, so room temperature is in between the two. This means that substance C will have melted below room temperature, but it won't boil until it gets to a temperature that's hotter than room temperature. So it's going to be a liquid at room temperature. Remember, each substance has different melting and boiling points, and therefore each substance could be a different state at any given temperature. Now this slide is for higher tier only, so if you're going to do foundation tier, you can skip this slide. Remember, if you look on the top right hand corner of the screen at any time, you'll be able to see whether the information is for higher tier only or for everyone. So for higher tier, you do have to be able to discuss the limitations of the particle model. This can sound quite complicated, but really it's quite simple. It's to do with the fact that we're using a model to represent something that happens in real life. This model represents particles as solid spheres with no forces operating between them, nothing that actually holds them together. But in reality, particles can vary in size and shape. They're not necessarily spheres. A particle could be one single atom, or it could be a really large molecule containing lots of atoms joined together, or even a charged ion. So particles aren't always spheres because they can change in size and shape. And they aren't really solid either because atoms are actually mostly empty space. In the models, there are no forces operating between the particles, but in reality, there are almost always forces that attract the particles together. In general, the stronger the force, the closer the particles will be. It's important to note here that the particles of the substance itself do not have the same properties as the overall substance. So the particles in a solid, a liquid and a gas are all exactly the same. It's the substance as a solid or the substance as a liquid or the substance as a gas that has the particular properties we've been discussing. Now that we've learned about the different states of matter, we need to know how to represent this in a symbol form as part of a chemical equation. State symbols tell us whether a substance is a solid, a liquid, a gas, or aqueous, which means that it's in a solution dissolved in water. Here we have 2 examples of equations. We have methane plus oxygen makes carbon dioxide and water. Methane is a gas made up of carbon and hydrogen, CH4. Oxygen is a gas. Carbon dioxide is also a gas, and water is a liquid. And we have copper sulfate and zinc makes zinc sulfate and copper. So here we have copper sulfate, and we write the formula for it with little brackets showing it's a solution, so that's AQ for aqueous. Zinc is a solid. Zinc sulfate is a solution, so that's AQ again. and copper is a solid. Here are some of the keywords that came up today in case you want to refer to them later. I hope you enjoyed this video, and I hope to see you again soon on another video by My GCSE Science.